Hello and welcome to PTC's virtual event, Designing for Manufacturability, How Alcon is Saving Time and Reducing Costs with Creo and DFMPro. My name is Emma Rantanen and I will be your moderator today. Throughout today's event, you will hear from Alcon as they show you how they are getting visibility into manufacturability using Creo and DFMPro. Before we get started, I'd like to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable, so feel free to move them around to get the most of your desktop space. You can expand your slide area or maximize it to full screen by clicking the arrows in the top right corner. If you have any questions during today's sessions, you may submit them into the Q&A widget at any time, and we'll spend the last few minutes of the conference answering them. If we happen to run out of time before we get to answer your question, we'll be sure to follow up with you after the conference. A copy of today's slide deck and additional help materials are available in your resource list. We encourage you to download any resources or bookmark any links you may find useful. For best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. If your slides are behind, pushing F5 on your keyboard will refresh the page. This virtual event will be recorded for replay purposes and will be sent out to all registrants as soon as possible. And without any further ado, I'd like to introduce our team of presenters. First, Alex Furman, Manager of Plastics and Mechanical Design at Alcon. Alex is a mechanical engineer with 17 years of experience designing and developing world-class surgical instrumentation for eye care industry. Currently, Alex is the Plastic and Mechanical Design Manager for Product Design Group at Alcon. His primary roles include leading and building resources, building technical skills and capabilities, and automating and streamlining the processes for the development of surgical instrumentation to support R&D activities. He has led and supported both plastic and mechanical design activities for surgical instrumentation research and development. He serves as an internal expert on subject matters related to plastics, Creo, and DFMA. Our second speaker is Navi Chandrasekaran, Head of Products and Technologies at HEL Technologies. Nambi has over 20 years in experience in product development and systems across industries, engineering, value chain, handling large portfolios of P&L and client success, and people management responsibilities. His focus areas include defining and delivering value for clients and outsourcing engagement that addresses product development challenges for clients. He has proven track record in leading growth and transformation initiatives focused on delivering business unit and vertical objectives and bottom line results in respective lines of business. And our final speaker for today is Jose Coronado, Director of Creo Product Management at PTC. Jose is the Director of Product Management for Creo Manufacturing Applications. He has a degree in Mechanical and Electrical Engineering, an MBA, and a post-MBA. He has over 30 years of experience in the manufacturing industry, ranging from being a CAD and CAM user in high-tech molding making facility to multiple technical sales consulting and product management roles at IBM and PTC. And without further ado, I'd like to hand things over to Jose to kick off today's virtual event. Jose, over to you.
Thank you so much. Hi, everyone. I'm very happy to be here today sharing this presentation with Alex and Nambi. My name is Jose Coronado, Director of Product Management at PTC. And I can start saying that there is so much happening in the industry and with technology that there has never been a more exciting time. I have been working on this industry for more than 30 years now, and I have never seen such incremental and meaningful change in how industrial products are designed and manufactured. Where we are today is that the world is in a very different place than even just a few years ago. Globalization is more prevalent than ever, allowing new competitors to emerge every day as barriers to entry lower. Smaller companies are being acquired or merged, creating larger companies with larger and often global footprints overnight. The way people work is changing as well. Location flexibility from geographically dispersed location becomes the norm. Increasing productivity remains critically important, Over the past 10 years, the productivity output of the manufacturing industry increased 1.2% compared to 2.6% from the 7 years prior. Since productivity of the manufacturing industry has a direct correlation to GDP output, it is critical that productivity remains a focus to ensure it remains on par with expectations. These macro trends are having an impact on the way engineering companies design and deliver products. There is a need for increased innovation to ensure that products are differentiated, allowing you and your teams to compete in an increasingly competitive environment. The skill gap continues to increase. Even though a large number of students graduate each year with engineering degrees, they are not always applying them into the manufacturing industry, but instead are applying their skills into roles at VC firms and startups, often allured by the Silicon Valley growth. Everyone is looking to do more in less time and accelerate time to market. As client demands increase and better products, there is an increasing need to account for these expectations while also delivering the products to market. Now, at the same time, the technology landscape has changed. There are new emerging technology trends disrupting the way design and manufacturing have been done in the past. This screen shows a recent report from Deloitte. The report speaks to the fact that new and emerging technology trends will change the industry. This is evidenced through many point solutions coming to market that focus on industry trends such as AI, IoT, or 3D printing. These point tools have accelerated the use of some of the emerging technologies for design. However, they are point tools and remain disconnected from the design process, leading to data silos, broken processes, and lost data. But what if you could harness emerging technologies such as AI, IoT, AR, additive manufacturing, etc., within your existing design environment and tools? Well, you can. At PTC, which is why I'm so excited to be here today, we are taking these latest technology trends and deeply integrating them into your design environment so that you, as a design engineer working in your everyday CAD tool, you can use them freely. PTC is the world's innovator of commercial 3D CAD, and we are now leading a renaissance of industrial design by delivering these integrated technology trends in Creo. Let me show you what I mean. At PTC, we're working on these 5 major areas, which happen to map very, very well to the major emerging technologies that Deloitte has outlined and that we know are critically important to you. I want to point out 2 really key things. First, we are not introducing point solutions. We are implementing and improving these areas directly into Creo. They will be integrated and be part of your existing workflow. Secondly, Creo scales across the supply chain. We can provide this technology not only to the manufacturer of an exhaust system, for instance, or any T1 or T2 supplier, but also to the major OEMs themselves. Creo is unique in its demonstrated market success in handling that kind of scale. Creo is the only industrial design tool capable for scaling and supporting at this level. And we're taking it to the next level by augmenting and the already robust functionality with the integration of this new technology. So let's go one by one. Taking a look at generative design. Generative design automatically generates optimal designs from a set of system design requirements. It brings together advanced analytics, artificial intelligence, and multi-physics simulation to automatically evaluate and evolve numerous manufacturing-ready design combinations that meet the design objectives, whether that is for additive manufacturing, milling, forging, or mold. Generative design will help challenge assumptions and deliver high-quality, lower-cost, manufacturable solutions. As we move across the workflow from generative design, we come to real-time simulation next with ANSYS. This enables not just powerful simulation to be conducted, but to be conducted as part of the design workflow. PTC is the only exclusive partner to be working with ANSYS that can bring this capability into the design environment. Everyone else has to utilize the same disconnected, siloed workflow where data handoffs are required, not with Creo and ANSYS. What real-time simulation is also doing is enabling the engineers to do things that weren't before possible. Engineers are able to see the influence of their feature creation or modification through the lens of the analyst. This is true simulation-driven design. Now, the simulation experts downstream will be able to get rich simulated models to perform their final validation. Next is the IoT-driven design concept. Here we talk about embedding sensors into products, which are collecting feedback and having it inform future designs. With Creo and the product insight extension, not only can you design your product to intelligently collect data as a smart connected product in the field, it can also be designed with connectivity in mind from the outset. Next is AR collaboration. With Creo, I'm able from within the design environment to quickly and easily produce AR experiences that enable stakeholders to not only visualize, but experience the design. You can easily share all your designs with stakeholders for design review and approval. Create experiences that enable designs to be viewed in context. Creo as a platform also connects from engineering to manufacturing, for sure. Seamlessly design, optimize, validate, and run up several print checks all in one environment, enabling you to easily bring designs from a virtual product to a physical product. Now within Creo, you can create your tray assembly, place your parts or components, nest them, and send them to the 3D printer. Now that we covered the trends and how Creo is being improved, let's look at a very important enabler to design for manufacturability.
Thank you, Jose. A warm welcome to everyone. I hope you and your families are safe. As Emma introduced in the beginning, my name is Nambi. I represent HCL. HCL is a world leader in engineering R&D services and solutions with over 150,000 employees and about close to $10 billion in revenues. It's a privilege for us to be the engineering partner of majority of the global top 100 product companies, representing almost all the major industry segments. Our products and solutions help our customers in their digital transformation journey. You heard Jose talk about some of the trends in engineering, and one of the major implications of that is increase in product complexity. We see this challenge manifest across almost all our customers as global competition continues to intensify and the pressure to differentiate increases. Products are being made more and more smart and connected, and that continues to increase the complexity. There was a survey done by engineering.com of leading manufacturers, and it came out that the #1 reason how the products are becoming more complex is because the mechanical designs are getting more intricate. I mean, as miniaturization happens and as you pack in more electronics and software content into these products, eventually your mechanical designs need to be able to accommodate, and that increases the complexity. Now, all of this adds pressure to the design teams, and if it's not addressed, it has direct implications to the businesses. The implications there are time to market, profitability, etc. As you can see from the chart on your left, over the last 10 years, along with the complexity, the efforts required to address the complexity demands have also grown by over 30%. However, as you heard from Jose, and as you can see from here as well, the productivity has grown by only about 2% or so, right? And this gap leads to delays in product launches. Delayed product launches has a direct impact on sales. And usually the sales that's lost due to this late launches are lost to competition or other sources. To address this, design teams have to increase productivity and eliminate waste. Now, the best lever the designers have to get more done with less is to reduce rework and design right first times. Reworks typically can account for up to 40% of total project cost, and more importantly, the later the rework happens in the life cycle, the more expensive and time-consuming it is to fix it. As you can see to the chart on the left, if the cost of change from rework is X during design, it increases to about 10X if addressed during testing phase or the build phase, right? And it increases exponentially the further late it happens. So there's a clear case for addressing it upfront. Now, reworks themselves can be due to many different reasons. Our survey and research shows that typically about 35% of the rework can be due to manufacturability or assembly issues. That's basically designed for manufacturability or assembly issues. And addressing them upfront during the design has tremendous benefits. Companies are realizing this, and they're adjusting their operational processes to handle many of the DFM, DFMA issues upfront. Now, the traditional approach, though, which is usually manual, is fraught with challenges and is not very scalable. For one, since there are hundreds of checks in DFM, there's always a chance that some of the key checks may get missed out in the manual process. Secondly, there is no closed loop to capture the learnings from the rework systematically and incorporate them for future validations. And finally, in the new normal that we all live, with more and more remote working, lack of proximity will be a challenge. Therefore, the solution is a software-driven approach in an easy-to-use CAD integrated environment. You heard Jose talk about the need for a single integrated environment for handling the product development process. Now, the automated approach saves time, ensures that all key DFM checks are completed upfront. And since it's in your native Creo environment, it's easy for designers to learn and use. HCL's DFMPro software is proven across many industries and leveraged by designers as a digital assistant to help design with confidence and design right first time. With this, I'll hand it over to Alex. Alex is from Alcon, and he'll talk about how Alcon is leveraging Creo and DFMPro upfront during the design process and reaping the benefits. Over to you, Alex.
Thank you, Nambi. Before I jump into discussion about DFM, let me tell you a little bit about Alcon. At Alcon, we develop innovative products to help people see brilliantly. We are the largest eye care device company in the world. We work in 70 countries and serve patients in more than 140 countries. Our leadership is driven by cutting-edge innovation and breakthrough technology, transforming the way we treat eye diseases and eye conditions. We have the widest array of eye care offerings in the industry, with products organized into two businesses, surgical and vision care. Driving innovation is the key to our business, and we have a history of launching new products to market for the first time, driven by strong R&D. So when we talk about strong R&D, it also means keeping up with our own innovation. As a company, we share the same challenges for developing products as the rest of the industries, such as driving innovation to ensure product differentiation, contending with today's product complexities, meeting milestones, onboarding of new engineers, or just keeping up with the ever-changing regulatory landscape. To be at the cutting edge of product development, you need to have the right tools, people, and processes. As you can see on the left-hand side of the screen is a typical device we design. This product is made up of very precise, intricate parts manufactured with different processes along with new innovative technologies, all packed into a sleek Alcon recognizable form that emanates performance, simplicity, quality, and innovation. Since it's all about the eye, which is the most complex sensory organ, it means a more complex product design. If you look at the graph on the top right-hand side, which depicts as the complexity increases, the time and cost required to find DFM issues manually go up, in turn, making it more expensive and longer to fabricate. But what if we can detect these issues while we design? This could drastically reduce this time and cost. So why aren't we doing it? Two reasons. Due to product complexities and concern with developing, prototyping, and testing to meet aggressive development milestones, the reality is there is no time to manually check for issues, and issues aren't discovered until we go into prototype or release to manufacturing. Another reason is managing the learnings and capturing of best practices is difficult. Most of the time, tacit knowledge remains with experts, and it's difficult to disseminate this knowledge across the organization. Also, while onboarding people from other industries, keeping them abreast with industry-specific knowledge related to DFM is difficult, as it's nearly impossible to just train people and expect them to remember all those guidelines. And not everyone is an expert on all manufacturing processes. But as Nambi points out, traditional DFM approach has its own set of challenges. Manual reviews are very time-consuming. There's a lack of knowledge and best practices available, and often difficult to locate these company DFM guidelines if they even exist. But what would it mean to have a design advisor recommend fixes based on your company's guidelines while you design? But let's first answer the question, why is DFM critical and why do we even care? Well, what about cost? Reducing cost without reducing performance. For example, minimizing part count, standardizing parts and materials, designing parts for loose tolerances, creating modular assemblies, streamline the number of operations in the manufacturing process. As you know, cost of engineering change is exorbitant during production, which may lead to rework, which may lead to delays. And as you know, delayed product launches have a direct impact on revenue and bottom line, including loss of market share. And knowing supplier capability and ease of manufacturing ensures good part quality that is easy to manufacture at a competitive price. Tolerances impact cost for manufacturing, and DFM highlights the risk of using such impossible to achieve tolerances for the manufacturing process. What about safety and efficacy? We must consider selecting materials for cleaning agents, fire retardants, and even water ingress. So, as you can see in the graph to the right, the time to incorporate these DFM measures manually are significantly higher as time goes on. But if we can automate this check process while we are designing, we could drastically reduce time and cost while increasing quality and getting it right the very first time. So how can we automate the DFM CheckPro process with our Creo platform? The answer is DFMPro, an add-on Creo application for manufacturing. So let's go see how this is done. The images on the top right-hand side depict a typical DFM guideline, and as you can see, it has many parameters that need to be checked before the design of even a rib can be added to a plastic part. Imagine trying to check on hundreds of parts and applying these guidelines manually. Also, as you can see, we use Creo as our design platform. It allows us to visualize the final product before steel is even cut. Allows us to create virtual parts, assemblies that make up the subsystem within our product, communicates design requirements to cross-functional design teams that all can see, and provide the capabilities and design tools to support all cross-functional design teams. DFMPro is an add-on that is directly integrated inside PTC Creo Parametric, adding manufacturability to our design platform. And with just a few clicks of a button, when we are designing, activates the design advisor. It's also linked to Windchill for DFM traceability. It also helps stage models for more expensive analysis like mold flow simulation, or even help start conversations with your vendors at the beginning of your project. Now, let me show you how we use it with an example. So open a part in Creo. Here's a plastic part, and in Design Advisor is activated to provide recommendations while you model. Just input the parameters and go. We have an option to analyze the part after modeling is complete, where we select the company guideline for this material, fabrication process, and click OK. Design Advisor will now select the pull direction, and all we need to do is input the material wall thickness desired and click OK. DFMPro is now comparing the part against each company's DFM guidelines for plastics, as you can see here. What is nice is now company guidelines are available for all design engineers, regardless of location, and now company guidelines can be updated in real time. This is the DFMPro interface, organized rules by criticality, and shows recommendations as well as the rules that pass. This part is showing no undercuts and no thin wall conditions. Here, you can see the recommendation to add radius at the base of the boss, and by selecting the instance, Design Advisor is highlighting the area of concern on the Creo model and allowing you to comment on the issues to fix for later review with the design engineer to go and add the recommended fillet to the model, which in this case is 16 thousandths. DFMPro also has a help menu that directs you to the content to give you further explanation on this specific rule and examples. Here are a few other rules, like minimum tip at the boss with examples, or minimum draft angle with an explanation why draft is important and the recommended parameters for core, cavity, and side pull classifications, or wall thickness where two walls are too close, resulting in thin wall conditions that can affect the quality of the part and reduce the life of the tool. There's even a section for recommended tolerances for ease of manufacturing. Tolerances that are too tight lead to higher costs and lower productivity. Here are a few examples of how DFMPro identifies mold dimensions from your CAD model. Now let's take another example, like wall thickness. Here it is, showing us that the base on the nominal wall, the recommended minimum wall for the plastic part is 58 thousandths, and the Design Advisor is flagging the area on the Creo model that is not meeting the guideline. I can also go to the scatter option and select multiple areas for analysis, and the Design Advisor highlights all these areas in Creo, which now allows us to add comments for the same issues all at once, saving us time. And now that we are done analyzing the results, we can go and create a report that will include all the recommendations and all the comments that have been inputted. Select the reports and click OK. Here is the Excel report with the company logo and list of rules analyzed. Let's pick one of these guidelines on this report, and we can see the recommendations for the guidelines, the actual values versus the recommended values, the comments we inputted during the analysis, including the associated image for these comments. We even have a section where we can provide action items, status, and additional team comments. The second report is a quick PDF report highlighting part being analyzed, when it was created, who created it, guidelines being used, fabrication process, results summary, number recommendation and its importance, and a summary of each general guideline with part images. That is DFMPro in a nutshell. Imagine all the time savings identified. A design advisor that identifies and recommends advice based on your guidelines that you can act on. A centralized guidelines of the latest company standards deployed company-wide. Tools for commenting, on-demand help, and 3D reports that organizes the recommendations, comments on an Excel report that can be used in a design review with no more time-consuming manual creation of reports. Simply doing more with less. In summary, having a platform like Creo, allowing stakeholders and teams to visualize the end product, communicating the design requirements, providing the tools for the design teams, coupled with Windchill for design traceability in one working environment, gives us a winning solution for designing faster with design traceability. Creo as a platform connecting to our manufacturing solution, DFMPro, we now have a winning solution for reducing costly design changes and reducing and possibly eliminating rework downstream, ensuring projects stay at the fast pace while reducing the worries of having downstream issues going into production. I'd like to thank everybody for allowing me to present to you today. It was my pleasure, and I hope that I was able to show you how Creo and DFMPro can save you time and money and do more with less.
As promised, we've saved the last few minutes of today's webcast to answer any questions you may have. If we happen to run out of time before we can answer your question, we'll be sure to follow up with you after the conference. I already see quite a few questions in the queue, so let's go ahead and get started. It looks like our first question is for Nambi. Can we add our own design standards and guidelines?
Oh, yes, absolutely. In fact, that's one of the power of the DFMPro platform, where apart from configuring what's coming as industry standard guidelines and rules, our customers can incorporate their own guidelines as well. I think you got a sneak peek of it when Alex was showing the demonstration where he picked an Alcon specific rule. So it's very much possible. It can be done.
Great. Next question. How easy is DFMPro to use and learn?
Well, I can start off, and Alex can add to it as a consumer of the product. It's fairly simple. You all saw the demonstration of the product, so it's completely integrated inside the Creo environment. It's a few mouse clicks to run the analysis, and then it's got very friendly reports. So we have noticed that our customers usually take about a day or two to learn DFMPro, and I will let Alex to talk a little more on that.
Well, to comment on Nambi, I found it fairly easy and it was very intuitive. If you see the demo performed several times, I think you should be able to pick up the basics in a couple hours. And if you need help, reach out to support. They're always responsive and helpful.
All right, next question is for Alex. How did you benchmark and what was the criteria used for selecting DFMPro software?
The first criteria was it needed to be compatible with our Creo platform. And the benchmark was, can the software approach to identifying DFM issues be faster than the current manual methods we were employing? And we found that the automated method was 100% faster. It identified issues I wasn't even looking for. And I got an added bonus with the automated design check reports, where the manual creation of these reports were tedious and time consuming.
Great, thank you. It looks like actually the next question is for Alex as well. Why did you start looking for a DFM solution?
Well, I was asked by senior management to organize and develop DFM guidelines for our product design group by gathering the resident experts in our group for machine, sheet metal, castings, and plastics, including our vendors, and apply these guidelines to our design check process. But being the design check process was very time consuming, I started researching DFM software, and I happened to run into DFMPro, where I set up and organized a demo at Alcon, and I guess the rest is history.
Awesome. So it looks like this is our last question for Nambi. Can we get dashboards?
Yeah, I think like the question, if I understand correctly, probably referring to metrics and things like that. Yes, DFMPro has an add-on module, analytics module, through which you can collect metrics, including the progression of a design, across each revisions and how many checks were completed. You can talk about how many issues were identified and fixed, who are all the people who are using it. So all kinds of metrics can be collected and dashboarded in the analytics module. Yeah.
Great, thank you. Next question looks like it's for Jose. About the technologies mentioned as IoT, AI, additive, and AR, when will be available for Creo user?
Yeah, no, this functionality is available today in Creo 7. Also, I can tell you that it's being improved as we speak for the next release as well. So we continue working on that. But it's ready to use as we speak. You can profit of that kind of functionality today if you want.
Awesome. And this looks like our last and final question, and it's for Jose. What is PTC's strategy with complementary third-party applications, such as DFMPro?
Well, PTC works closely with key partners as HCL to develop and deliver fully integrated applications which can work inside Creo in a way that the designer or engineer can continue using the same workflows as it was shown on Alcon's DFMPro implementation.
Ladies and gentlemen, that's all the time we have for today for questions. We apologize if we didn't get to your question, but we will follow up with you via email. As I indicated earlier, this conference was recorded and will be emailed to all registrants. I'd like to thank each of our presenters for delivering such great content today, and I'd also like to thank our audience for attending each session. We hope you find this event valuable, and thank you, and hope that you'll return for future PTC webcasts.